Okay, welcome back. This is kind of behind the scenes. I want to wrap up this C programming CLI. So to put some of the finishing touches on it, I wanted to use Windows indirectly. Well, use Debian indirectly from Windows to build a Debian package to make a good developer experience. So it's just like one click of a button, or you just run some command line. So let's get started. So there's a couple things with before we make the Debian package. We have to actually set our. I want to use Docker. We have to use our DockerCompose because you can't make a Debian package on Windows, from my understanding. And I don't want to make a Debian package on Windows. It's for Debian. So I wanted to put a build system in place to build my package, my Debian package, without anyone have to repeat my steps, like intensive steps, and repeating and reinventing the wheel. So let's start first with my Dockerfile. I actually just did something a little simple. We can like spaz this up a little bit, like because this is not being used for production. The only thing we have to worry about is how we compile the binary and sign it, or the dev package or anything like that. So what I did was I started with a Docker file for a build system. So I'm going to use this image right here, do a couple provisionings, such as making the build essentials. And what I want to do is I'm going to mount my Windows directory to my Docker container. I want to build a good developer experience where anyone can do this and not worry about what platform they're using or anything like that. So these are some of the provisions that I did for my particular Docker file. So the next piece is the Docker Compose file, which is the driver to do the build. I don't want to go regular Docker. I want to use Docker Compose so I can do a Docker up and spins down. This is very important because when you use the Docker file, you will get multiple instances of your container. So here I can name my container and just use that instance every time I do a build. Just use that one instance and not have all these different containers piling up on my system. So this is one of the ways that I did that. And so what I did was I injected my Docker file, which my Docker is going to use my Docker file to do the build. And then I set the context as to the directory that I'm going to pull resources from. And then right here, this is interesting right here. So this is for my Debian template. Okay. I made it where we can change these different things from outside of the Docker instance before we run it. So, and also what I did was I attached the opt build inside of the container to this current directory I'm working in. And then the TTY true is really not going to help us out or anything like that because this Docker is going to spin down because of this command I run here. I didn't use a command to keep the Docker container running. I did an override on whatever's in this Debian image to keep it running. And we're not using this for to give a service. We're using this just for a build. And also, it's a bad practice for production. Anything that's going to provide a service to a some customer or client, you don't put the build tools on the actual production server. I see a lot of people do that, and you don't do that. You make it where you cannot build on that server. The only thing you can do in the production server is run the service and add libraries to the service. Okay, so that's rule number one. Don't put your build libraries or whatever you need to build binaries on your production server. You're just asking for security issues. You're asking for exploits. Also, the only thing you need on that production server is runtime. That's it. So like JDK versus JRE, JREs go on production ready servers. JDKs go on development servers or the server that's going to actually build the application. All right. All right. So now right here we have the build sh. Now the build sh, once everything is up and running, I run this build sh to actually build my parameters for the control file of the Debian package. So these are the instructions for the information on the Debian package. It's going to put these values that I have, and I'll show you these values, and it makes it like a template, so you don't have to keep writing a file or go on the file and change it. You actually don't even need this file. This is dynamically generated, a dynamically generated file using batch scripts. Using sh scripts. Another thing is, make sure in your corner right here, whenever you're doing shell scripting, you set the settings in the Visual Code from the CRLF to LF, okay, for the Linux file system, okay? Because what's going to happen is when it interprets this shell script, it's going to put a lot of garbage behind it if it puts it in a Windows format or that other format that I showed you. The interpreter get all mixed up, and because those symbols are not valid for SH scripting, maybe for PowerShell, but not SH scripting. So I changed this to the LF, okay? So let's go to our env. So this is the injection point right here. These are the environment variables that I inject into the DockerCompose, and the DockerCompose inject those into the container. Also remember, the commands are to be ran after the container is running, not during the build of the container. So after container is up and running, that's just how I like to do it. And what I do is do a build out here, where that command that you see right here is going to actually build that container. Build that binary and build the Debian. Also, you get to see where the makefile stuff comes in handy. So my makefile will actually be ran, and then I copy the binary or everything we need to the bin folder right here into the Debian package, and then I call the Debian package to do a build. And if you notice, I templated this so that you can change your packaging names and stuff like that just by controlling this environment file before running. So let's give it a shot. Let's take this right here. Let's delete it. And also the C programming, it's going to clean this stuff up. So in my script, I actually make it where it does a cleanup before it runs, because this container is persistent because it's attached to this file system, and I want that Debian to return to me, okay, where I can grab that Debian and it's not in the container. And when the container powered down, it just caused all, we can't get the Debian package unless for security purposes you want the Debian package to build and the container just push it up to the artifact repository. So I do a cleanup, and be extra careful. I do a cleanup right here, okay, because if you do a cleanup right here, you can possibly delete all of the files that are in here, but this is why we have source control, okay? So be careful on that. I have some advanced, some very basic Linux commands in here. Some of them are advanced. If you're interested in some shell scripting, please, I can post some material for it, but just let me know if you want me to post some shell scripting material. I do plan on showing some shell scripting in depth, but just for the purpose of this video, I just want to show you the proof of concept that everything is working. Even our binary is working, okay? So now, and our makefile will show that. So now, if we go here and we do the DockerCompose build, and you will see that Debian file pop up soon after everything is done building, and we'll look at some of the logs as well. Might take it a minute. There we go. That's what we want. One caveat to this is the builds might take a little bit longer. Sometimes it's best to use like Jenkins or something like that to do your builds. But I just want to have a good isolated developer experience. You can do that with Jenkins as well, but you have to separate between your jobs, production, and all of that, and then put some hooks in. And I can show that too, where I can put hooks into my Jenkins configuration, where it's just a build for me or build on a certain branch, every time I commit something, but that's an advanced subject. So now we're going through, we're building the Debian package, and we're running the make file. So the make file should run next. Let's see. Let's kind of expand this a little bit. Okay. So we got starting Debian package. Right here, the vulnerabilities for the image. There's a couple of instructions I pulled out of it because this is just for, proof of concept purposes. I haven't, and let me be clear, I haven't hardened the image, but we don't need to harden it because we're doing development stuff. So we're doing our build, and this is the crazy part. Well, the great part is that our binary is actually going to work as a CLI. So as you saw, look, it's rebuilding everything, and look at that. The C programming deb has been created again. Okay. So now, look at our CLI right here. We added a 2 plus 4. We got a 6. We did a subtraction of 44 minus 67. So it's 111. Which this right here might be wrong right here. I might have did something crazy with it. And then right here, you see how we have info? Our invalid command right here is working properly. Okay. So it could be that something is mixed up between here, but after all, it's working. But we just have to figure out what this bug is right here, and that's in the router. So that's something that I fix. But it shows that commands are coming out of the stack. The dev package was built. And let's go and check a couple things here. The user bin, there's the driver right there. And then that Debian control file that we made, see that right here. It injected everything that I had. And there we go. I am going to put this into source control, and I might release it. So have fun. Take a look, dive deep into it. If you're interested, hit the like button, hit the share with others. Thank you.